Hey guys, we are going to start 10.6 in our circles chapter. So we're going to talk about some other types of angles. Before we talk about these other types of angles, we just want to do a quick little review of the type that we've learned so far. So a central angle. Let's remember that a central angle and its intercepted arc are equal. So x is 80 degrees. These are equal. An inscribed angle, if they give you the angle measurement and they want to know, if they give you the arc measurement and they want to find out the angle measurement, we just need to take half. So if the arc is 80 degrees, the angle is 40 degrees. Now remember, when we have a radius that meets a tangent outside of the circle, it always forms a 90 degree. So we have 90 degrees there for x. And inside a circle, if we have an inscribed quadrilateral, there's a special relationship between the angles that are across from each other. These angles are supplementary, which means they add up to 180 degrees. So x plus 80 equals 180. If we subtract 80, we know that x equals 100. So these angles are supplementary when they are across from each other. Okay, so that was a quick little review. Now we're going to learn a couple of different types of angles. So the first thing that we're going to talk about are when we have two chords inside of a circle. So we have our two chords here. We have chord AB and we have chord CD. So when I look at this example and I look at these other three examples, I kind of see something that looks like a plus sign. It looks like a multiplication symbol also, but when they cross in the middle there, it kind of reminds me of a plus sign. So what you have to do in order to figure out this angle inside here, angle 1, what we have to do is we have to add up our arcs. So what I would do here is I would add up arc AC and I would add up arc DB. And then what I would do is I would take half. So I would divide by 2. So we have to add our arcs and then divide by 2. So let's take a look here. To find out the measure of angle 1, if we know that arc AC is 70 degrees, so label your diagram, and BD is 50 degrees. So if we follow what we did up here, I'd have to do 70 plus 50, and I would divide by 2. So we get 120 divided by 2, which equals 60. So the measure of angle 1 equals 60 degrees. So the reason I said it kind of looks like a plus sign is because it's part of the formula, so I know I have to add the arcs. So let's take a look at our examples down at the bottom here. We want to figure out the missing angle, which is angle 2. Now, if you look at these examples, you'll see this dot in here. That's just the center point. Okay, so we're going to ignore that. We have to figure out the measure of angle 2. So, like above, I want to take my arcs, and I want to add them up, and then I want to take half. So I'm going to divide by 2. So for number 2, I want to take 40 plus 30, and I want to divide by 2. 40 plus 30 is 70 divided by 2. So the measure of angle 2 is going to equal 35 degrees. All right, so let's take a look at number 3. Let's take a look at my arcs. I've got 100 degrees and 88 degrees. Do you see how the 3, we have to figure out what angle 3 is? It's lined up with these arcs. If the 3 was over here, we wouldn't be able to just add these arcs. If the 3 was here, we'd have to add these 2 arcs. So the angle placement is very important. So we're going to add 100 plus 88, and we're going to divide by 2. So we get 188 divided by 2, which equals 94 degrees. So the measure of angle 3 equals 94 degrees. Now let's take a look at number 4. We have to look at our arcs. Our arc is 100 degrees, and this arc is x. So that's a little bit different. Usually the x, or the angle we've been looking for, is inside the circle. So we still set it up the same way. We add our arcs. So we take 100 plus x, and we divide by 2. And we set it equal to what we're looking for. We've been looking for this angle measure. So I want to set it equal to the 75 degrees inside. Now I don't like working with the fraction here, so let's multiply by 2 on both sides to get rid of it. The 2's on the left go away, so we have 100 plus x left. 75 times 2 is 150. Subtract 100, and x equals 50. All right, so let's turn the page here. So your second page. All right, so now let's go over some quick definitions here. We've talked about what a tangent is. So let me draw an example. A tangent is when we have a circle with a center point, and the tangent is a line that just touches the circle at one point. You can also have a circle, and you can have just part of that tangent drawn. All right, these are both considered tangents. Now, something we haven't talked about yet is a secant. A secant is in a circle, and it's a line like a tangent, but instead it goes through the circle twice. So it intersects the circle twice. All right, so we are going to learn 3 things about circles when they have tangents, or when they have secants, or when they have a tangent and a secant. So our first example is when we have 2 secants. Okay, so we have 2 secants going through the circle meeting at a point here. We have 2 arcs. We have arc X and arc Y. So these arcs here. All right, these correspond to this angle 1 inside. All right, so to figure out what angle 1 is, we would have to take these 2 arcs and we would subtract them and then take half. So we would do x minus y. Ooh, let me correct that. X minus y, and we take half. And that would give us angle 1. So for this example, we're going to subtract. To me, it looks like 2 minus signs. So that's how I know I want to subtract the arcs. Now let's take a look here with 2 tangents. When I have 2 tangents, here's one arc. Here is my other arc. All right, so those 2 arcs make up that entire circle. Guess what? Same formula. I want to take the arcs, x minus y, and I want to take half. And that will give us angle 2. All right. Let's take a look at when we have a secant and a tangent. So we have a secant going through the circle, and then we have a tangent touching the circle once. Take a wild guess what the formula is going to be. It's going to be the same exact thing. So we have our first arc, and we have our second arc. We are still going to subtract the arcs and divide by 2, and that will give us angle 3. So each time here, we are going to subtract the arcs, and that's what gives us our angle measure. So let's take a look at a few examples down below. All right, so all we have to kind of do is kind of look at the picture and kind of match it up with what's above. So let me show that part. So for number 5 looks to me like we've got 2 secants, right? Let's write that down. 2 secants. So I know I want to subtract the arcs, and it will give me the angle measure. So my arc is 120, my other arc is 40. 120 minus 40, and I take half, will give me angle 2. So 120 minus 40 is 80 divided by 2, which is 40. All right, let's take a look at number 6. All right, number 6. So you might look at up here and say, oh, this doesn't look exactly like one of them. Well, if I look at the two tangents, if I just get rid of those parts, doesn't it look like this one down below? So it's still the same formula. So I need to know both arcs. I know that this is 260, but do I know what this guy is? I don't know, but I can figure it out because there's 360 degrees inside of a circle. So 360 minus 260 will give me 100. So this arc is 100 degrees. So we do 260 minus 100, and we take half, divided by 2. 260 minus 100 is 160 divided by 2, which is 80 degrees for angle 4. All right, number 7. Number 7 looks to me like a secant and a tangent. Same formula. Subtract the arcs, divide by 2. 170 minus 80 divided by 2 is 90 divided by 2, which is 45 degrees. All right, let's take a look at number 8. Number 8 looks like two secants to me. So we want to subtract our arcs, and it's equal to the angle measure. So we want to subtract the arcs. So 130 minus x divided by 2 equals our angle measure, which is 40. I don't want to have that 2 in the bottom. Don't want that fraction, so I'm going to multiply by 2 on both sides. The 2's go away. 130 minus x equals 80. Subtract 130. Subtract 130. Negative x will equal 50. I don't want to know what negative x is. I'm sorry, negative 50. I don't want to know what negative x is, so I have to divide by negative 1. Oh, let me move that. Divide by negative 1, x equals 50. So still, even though there's an x involved, it's the same formula. All right, let's look at number 9. Number 9 is going back a little bit to when we have a chord and we have a tangent. When we do that, all we have to do is take this arc measure and divide by 2. So we still just take what we have and divide in half. So 170 divided by 2 is 85 degrees. Now number 10. Number 10 looks a little complicated, but if we break it up into two parts, it's not. So let's look at the top half here. In the top half here, this looks like two secants. So that's the first example on your page. Take the arc, subtract them, and divide by 2. So for the first one, for angle 1, we're going to do 70 minus 26 divided by 2, and that will give us angle 1. So 70 minus 26 is 44 divided by 2, which is 22 degrees for angle 1. So that's the first part of this problem. That's this part right here. Now the second part down here looks like we have a secant and we have a tangent, which looks like the third rule that we talked about. Again, follow the formula. Subtract the arcs. Subtract your arcs right here and right here. 120 minus x. Take half and it equals your angle measure, which is 40. So we don't want that 2. Multiply by 2 on both sides. 120 minus x equals 80. Subtract the 120. All right, we're going to get a negative number, no big deal. All right, so we've got, I'm going to write over here, negative x equals negative 40, but we don't want to know what negative x is, so I can change both sides, signs, and x equals 40.